Okay, this video compares two related rates problems that are both volumes. So let's just look at what we're given. So we are given 9 centimeters cubed per second as the rate of change of the volume. When they say blowing up a beach ball, that means the volume is changing. So that's your given. And you've been given what the actual volume is at a moment. On the other equation, you are given a cylindrical container with a radius of 4.5 inches, and you're given that the height is increasing. So the two things you're given are the radius, which equals 4.5 inches, and the height. So in the beach ball equation, you want to find the rate of change of the radius. So you are looking for dr over dt. And in this equation, you're looking for at what rate is the volume increasing. So you're looking for dv over dt. So those are our two unknowns. So these equations are very, very similar. We're going to take the derivative always. So we've been given dv dt here, and we're looking for dv dt here. So in both of the volume equations, we need to take the derivative. So here's our volume equation and our general equation, not like what our volume is, but our general equation. Anything that's changing, we're not going to plug in. But if we have something that is constant, that is never changing, we should plug that in before we differentiate. What happens when you differentiate is you are actually finding a rate of change. dv over dt is the rate the volume is changing. So to do that, you have to differentiate both equations. However, before you differentiate, you should replace anything that is constant just to make your work easier. For instance, in this equation, if you differentiate, there are two different variables. So you would have to do the product rule, which is first times the derivative of the second plus second times the derivative of the first. So it'd be r squared times 1 dh dt plus h times 2r dr over dt. Gross. If we can avoid that, we want to. I want you to notice this is a cylindrical can, and that means the radius is never going to change, okay? The volume of the rice is, so if you have a little bit of rice in here, that's where it is, maybe a little bit more and a little bit more, right? So you're going to have more volume in this can of rice, and that's what's changing, right? And the height also of rice in the can is changing. However, the radius cannot change. So what I'm going to do here is I'm just going to replace my radius with 4.5 squared, because I don't want to differentiate that, because I don't need a rate of change for the radius, because the radius is never changing. I only differentiate things I need the rate of change for. Now I can differentiate both equations. So since we're talking about the rice one, let's do the rice one first. So v becomes dv over dt, and 4.5 squared pi is just a constant. 4.5 squared pi is a constant, and the derivative of h is 1 dh over dt. So that's how to differentiate that one. On this side, same thing, dv over dt equals, and when I differentiate this, I've got to multiply 3. It's going to be 3 times 4 over 3 times r pi r squared dr over dt. So anything that's a variable has to get the dr over dt, dv over dt, and at this point I can then go plug things in. So I know my dv over dt already, and my dv over dt is 9 centimeters cubed per second. And on the other side, that gives me 4 pi r squared dr over dt. Now I'm trying to solve for dr over dt, and so at this point I have an extra variable. I have this variable of r right here, and I don't know what it is, but I can't solve for dr dt until I find out r. But I can actually do that because earlier in the equation I was also given the volume. So I just, since the volume equals 4/3 pi r cubed, I just plug in the volume. 2048 pi over 3 equals 4/3 pi r cubed, and I solve for r. And when I do that, I get r equals 8. So I'm going to replace this r right here with 8 to solve the equation. Now I just need to get dr dt by itself right here. So I'm going to multiply both sides by 1 over 4 pi times 8 squared, and that will get rid of it on this side. And on the other side, I'm going to multiply it by 1 over 4 pi 8 squared to get my final answer. So when we plug that into our calculator, dr over dt is going to equal 0.011, and this is going to be in centimeters per second because radius is a linear measure, so it is in centimeters. On the other side, to finish this one, we actually have everything we need. We are looking for dv over dt, and we do not have any more variables on this side except we do have dh over dt. So dv over dt, and I'm going to put my units back in here, equals 4.5, and radius is inches, right? Squared times pi times dh over dt, which recall was 0.5 inches per second. And that gives me dv over dt equals 31.809 inches cubed per second, because first of all, it's volume, so volume is a cubic measure. Second of all, we had inches squared here, and then inches per second here, which gave us our units. I hope this helped. Thanks.